In this video, we're going to look at derivatives of the other trig functions. There are four new formulas that we want to be familiar with. The derivative with respect to x of tan x is secant squared x. The derivative with respect to x of secant x is secant x times tan x. The derivative of cosecant x is negative cosecant x cotangent x. And finally, the derivative with respect to x of cotangent x is minus cosecant x squared. Now there's one fact that I'd like to point out. It just makes learning these formulas a little bit easier. Notice that the derivatives of tan x and secant x just involves secant x and tan x in some way. So in this way, we can think of tan x and secant x as partners. Similarly, the formulas for the derivatives of cosecant x and cotangent x simply involve these same two functions in some way. And in fact, if we think back to what we said about sine and cos x, the same is true for these functions as well. Remember, the derivative of sine x was cos x, and the derivative of cos x is negative sine x. So again, sine x and cos x are partners for the same reason. So this pattern here does help us a little bit when we're learning these formulas, but really the best way to learn them is just to do some repeated problems. So let's try a quick one now. Let's start with the function f of x is secant squared of 2x plus 1. Now let's see if we can find f prime of x. First thing I would do here is I would rewrite the function. Notice that we've got a positive power on our trig function. And so the way the function is written here is really just a shorthand. F of x is the exact same function as secant of 2x plus 1 all squared. So we're going to have to use the chain rule when we find the derivative of this function. And in the chain rule, it's really important to be able to identify the outside function properly. And I find that if you write the function in this way as your first step, then you get the outside function right and you get the question off to a good start. So let's work on finding f prime of x. Well, according to our chain rule, we're going to take the derivative of the outside function, so the squared function. That 2 is going to come down in front. Our inside function is going to stay the same, and the power will just be reduced by 1. So really, first power here, we've got 2 times secant of 2x plus 1. And then we need to multiply by the derivative of the inside function. Now I'm going to leave that calculation for the next step, because otherwise we're going to have a lot going on here. So let's try to just do one step per line. Okay, so first step there, that was the chain rule. We took the derivative of the outside function, kept the inside function the same, and then we multiplied by the derivative of the inside function. So now in our next step, we have to work on this part here on finding this derivative. Okay, well, let's clean up as we rewrite this. We've got 2 times secant of 2x plus 1, and we're going to multiply by the derivative, whatever secant of 2x plus 1 is. So we can give ourselves a big set of brackets here, and that will help us organize our derivative. Well, looking back to this step here, the outside function is the secant, so we're going to take the derivative of the secant function. And remember, if we look back at our formulas over here, anytime we're taking the derivative of secant of an angle, the answer is going to be secant of that angle times tan of that angle. So we're going to get secant of 2x plus 1, probably going to need a slightly bigger bracket here, so secant of 2x plus 1 times tan of 2x plus 1. We have now taken the derivative of the secant, but we need to now multiply by the derivative of the inside function, so times 2. Okay, and again, this comes from the chain rule because we've got derivative of the outside function, keep the inside function the same, and then times the derivative of the inside function. All right, that is all our derivatives done. So we just got now a little bit more organizing to do. Our total coefficient in front, because everything here is multiplied together, we're going to have a 4 coming out to the front. And it's a little bit faster if we actually combine these two secants. Remember, they're being multiplied together, so we could really say secant squared of 2x plus 1 times tan of 2x plus 1. And that's a good final answer right there. For our next problem, let's let f of x equal x times cosecant of x over 3. And our problem here is going to be to find f prime evaluated at x equal pi. So let's start on finding our derivative. Well, when we look back at our function, notice that it's written as a product. We've got x times cosecant of x over 3. Okay, so we're going to use the product rule here to start finding our derivative. So we'll take our first factor x and multiply it by the derivative of our second factor. I'm going to leave this calculation here for the next step because we really want to just focus on getting the product rule set up properly. So first factor times the derivative of the second factor plus the second factor, cosecant of x over 3, times the derivative of the first factor. Well, first factor here was just x, so its derivative is 1. If the derivative's easy enough to write down, I'd just write it down there, but I think it's probably a better move to leave this calculation here for the next step. All right, so now we can focus on finding that derivative of our cosecant function. So if we just recopy from our previous step, we've got x times, and if we think back to our formula, the derivative of cosecant of a function is going to look like negative cosecant of that function times cotangent of that function. So we're taking the derivative of the outside function, leaving the inside function the same, and then we're going to multiply by the derivative of the inside function. All right, so that is an application of the chain rule. We've always got the 3 parts to the chain rule, taking the derivative of the outside function, multiplying, and then writing down the derivative of the inside function. Then, continuing to recopy here, we've just got a plus cosecant of x over 3. So we can organize our work a little bit. In our first term, everything here is being multiplied together. So we could write it as minus x over 3 if we bring the -1 and the 1/3 to the front. And that's multiplied by cosecant of x over 3 times cotangent of x over 3, and then plus cosecant of x over 3. All right, so that now looks relatively simplified. Now in this problem here, remember that we were trying to find f prime of pi. So let's go ahead and plug in x equal pi. We'd have minus pi over 3 times cosecant of pi over 3 times cotangent of pi over 3. So just replacing all the x's here with a pi over 3. So let's draw a right triangle here. We've got angles pi over 3 and pi over 6 in this particular triangle, and our side lengths are going to be 1, root 3, and 2. So that's a triangle that we should be familiar with. Now thinking back to SOHCAHTOA, let's say we want to calculate cosecant of pi over 3. Well, first thing we need to remember is that cosecant is the reciprocal of sine. So if sine of an angle is opposite over hypotenuse, then cosecant is going to be hypotenuse over opposite. Okay, and if we grab our angle pi over 3 here, with respect to this angle, the opposite side is root 3 and the hypotenuse is 2. So we get 2 over root 3 here. To get cotangent of pi over 3, well, let's remember that tangent is opposite over adjacent. So that means cotangent is going to be adjacent over opposite. And again, looking with respect to the angle pi over 3, the adjacent side is 1, the opposite side, root 3. What we're doing here. We're getting f prime of pi, and coming back to this step here, we can plug in. We've got minus pi over 3 times, we said cosecant of pi over 3 was 2 over root 3. Cotangent of pi over 3 was 1 over root 3. And then we're adding on, again, our cosecant of pi over 3 value. All right, so as we start to clean this up, our first term looks like negative 2 pi all over. Well, if we look at our denominators here, the root 3 times root 3, that gives us a factor of 3. So we're really getting 9 in the denominator here. And then for our second term here, it would be a good idea to rationalize this denominator. So instead of writing 2 over root 3, let's think of multiplying the top and bottom here by root 3. So this is really a 2 root 3 over 3 if we rationalize the denominator was what we did right there. Okay, so just getting the square roots out of the denominator. Now, to give a final answer, it would be nice to have a common denominator. So we get negative 2 pi over 9 plus, let's take our 2 root 3 over 3 and let's just multiply it top and bottom by 3 so that we get a common denominator here. And that way we can give our final answer. So really we're looking at minus 2 pi plus 6 root 3, and that's all over 9. So there's our final answer there.